All right, let us solve this simple calculation on measurements and bounds. Three quantities, T, U, and V, are related by the expression P equals Q over R squared plus or minus 0.5, and R equals 2.5 plus or minus 0.5. Write down the inequality that shows the range of values of P. The inequality that shows the range of values of P. So this means we're talking about the upper and lower bounds of P. So we will be expected to present our answer in the form P lies between the lower bound of P, which is P minimum. So invariably we're asked to find the minimum value of P and the maximum value of P, P maximum. At the end of our calculation, our answer is expected to be presented in this form. Okay, let's get into it. First, P depends on the values of Q and R given to us from beginning. So let us establish the lower bounds, upper bounds of Q and R. Let's go. Q is given as 4.5 plus or minus 0.05. In this writing, 4.5 is the rounded value or the estimated value, while 0.05 is the possible error. So from here, we can have the lower bound of Q, which is also the minimum value of Q. Q minimum is going to be 4.5 minus 0.05. And this is going to give us 4.45 as the minimum value of Q. In a similar manner, we can get the maximum value of Q. So Q maximum is going to give us 4.5 plus the possible error, which is 0.05. And now we have 4.55. Beautiful. So we have the maximum and minimum value of Q. And we have to do the same operation for R. From the expression of R in a similar manner. So I can say also from the expression of R, which is 2.5 plus or minus 0.5, indicating that the rounded value or the estimated value of R is 2.5, and the possible error in the measurement of R or the computation of R is 0.5. So we can get the lower bound for R, which we write as R minimum, minimum value of R. And that's going to be by subtraction, 2.5 minus 0.5, giving us 2.0. That's right. And now the upper bound of R, which is the maximum value of R, we write as R maximum, is going to give us, this is by addition, 2.5 plus 0.5, the possible error. And this gives us 3.0. Beautiful. With these four details, we can solve the problem. Now let us establish the minimum value of P from our relationship. P is given by the interaction between Q and R in this manner, Q divided by the square of R. And therefore, we can have the minimum value of P. Now you need to study the full video on measurements and bounds that I've produced. I've given the link to the video in the pinned comment. You just click the link in the pinned comment and then you can study the full video here. Because we want to find the minimum value of P, it will occur when the numerator is at its minimum and the denominator is at its maximum. So minimum value of P will be given by Q minimum divided by maximum value of R, R maximum. And don't forget, the value of R is to be squared. So let's evaluate this. This is going to give us the value of Q in the minimum is 4.45. Divided by maximum value of R, which we can pick up from there, that is 3.0. 3.0, and we have to square this. And this gives us, by using with the aid of an electron calculator, gives us 0.49. 0.49, that's right. Now, in a similar manner, we can continue the calculation right here in this space. In a similar manner, we can get the maximum value of P maximum. And because the expression for P is a fraction, it will be obtained when the numerator is at its maximum. So we have Q maximum divided by, and R has to be at its minimum. So we have R minimum. And remember the square around R. So when we substitute values, the maximum value of Q, right there, 4.55, divided by the minimum value of R, which is 2.0. And let us remember it is being squared. And this is going to give us P maximum. It is going to give us, of course, 1.14 with the aid of an electronic calculator. Beautiful. So we have P maximum and P minimum. Now the inequality. Write down the inequality that shows the range of values of P. So for the range of values of P, the range of values of P, and it is given by, we have P lying between. And that's the inequality we started with from beginning. And that's it over there. Minimum on the left-hand side, which is the lower bound for P. P minimum, 0.49. We have decided to leave our answer to 2 decimal places. And then the maximum value of P, which we have there, 1.14. This gives us the range of values of P. And that's very simple, our final answer. Very, very simple. That's right. Now, please subscribe to this channel, like this video, and share with friends to facilitate learning. If you want to really study the full lecture on measurements and bounds, please click on the link provided in the pinned comment below. And then you can make a request on topics that you would like to study in another video. Until I see you in the next video, I'm your special coach, and my name is Temple AK. Until we meet, keep up your good practice and then stay blessed. Bye for now.